Hello everyone. In this particular video, we are going to solve the problem from Irodov, that is problem number 1.7, and which is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. So there are two swimmers who are swimming from point A on one bank of the river to reach point B, which is lying right across on the other bank of the river. So these are the two banks of the river, and this is point A, this is point B, point A and point B, and the swimmer wants to move from point A to point B. Okay, so one of them crosses the river along the straight line AB, while the other swims at right angles to the stream and then walks the distance that he has been carried away by the stream to get to point B. Now we have to understand what these statements are trying to convey. So let us first talk about the first swimmer. Okay, so these are the two banks of the river. This is point A, this is point B. The swimmer is going in the direction from A to B. So in this particular direction, the swimmer is not swimming, but actually it is going in this particular direction. What is the meaning of saying it that? For example, the stream is having the velocity in this direction and it is flowing with the velocity of, let us say, Vst. And because of the stream velocity, for example, if the swimmer will swim in this particular direction, then it will go in this direction and it will reach somewhere else because of the stream velocity. As it is going in this particular direction, the swimmer has to swim in this particular direction, so that because of the stream velocity it will again go in this particular direction. So first swimmer is actually doing the same. The swimmer is swimming in this particular direction, and because of the stream velocity it is going in this direction. Now what is this one? So when we keep the stream velocity at rest, let us say, then this is the direction in which the swimmer will go with the velocity, let us say v1 with respect to stream, and this is the stream velocity and this is the actual velocity of the swimmer. Okay, now let us talk about the second swimmer. Second swimmer has started traveling. I started swimming from point A to point B in this particular direction. So it is, if you read it carefully, then it is saying that other swims at right angle to the stream. So this is the stream direction, and it is swimming in the right angle to the stream direction, and because of the stream velocity it will not go in this direction, it will go in this particular direction and it will reach somewhere at point, let us say, C. Now what was the velocity u of each walking if both swimmers reached the destination simultaneously? So basically it has reached to point C. Now it has to go from point C to point B, so that it has to walk on this particular bank of the river with, let us say, velocity u. And it is saying that time taken to cover the distance from A to B for swimmer 1, let us say t1, and time taken to cover the distance from point A to point C is, let us say, t2, and the time taken to travel from point C to point B, let us say t3, and in the question it is stating that t1 is equal to t2 plus t3. Now if we talk about the swimmer 2, then swimmer 2 is actually moving in this particular direction, swimming in this direction with what velocity? With velocity v2 with respect to stream, and this is the velocity, that is v2, and this is the velocity of the stream, and later on after reaching C it is moving in this particular direction with velocity u, and then the stream velocity is given as 2 kilometer per hour, and the velocity of one with respect to stream it is given as 2.5 kilometer per hour, and this is also given as 2.5 kilometer per hour. Now let us analyze the motion of both the swimmer mathematically. So let us first consider the first swimmer. So these are the two banks of the river, and first swimmer is swimming in this particular direction, and this is the stream velocity vst, and this is v1 with respect to stream, and then this is point A, this is point B, this is v1. Okay, so from the this is what 2.5 kilometer per hour, and this is 2 kilometer per hour. So from the triangle we can say that v1 is equal to v1 st whole square minus vst whole square under root. So what is this value? 2.5 whole square minus 2 whole square under root. So we'll get 1.5 kilometer per hour. Okay, and let us assume that this particular distance is d, and it is taking t1 time to cover this particular distance. So we can write velocity 1 is equal to distance upon t1. So 1.5 is equal to distance upon t1. So this is our first equation. Okay, now talking about the second swimmer. These are the two banks of the river, and from point A to point B the swimmer has started swimming in this particular direction, and because of the stream velocity it is moving in this direction. Okay, so this is v2 st is equal to 2.5 kilometer per hour, and this particular distance is d, and we have said that from A to C it is taking time of t2, and at point A the actual velocity of the swimmer is having the vs2 in this particular direction and vst in this direction. So we can write v2 st is equal to d divided by t2, or we can also write, let us say this particular distance is d1, then we can write vst is equal to d1 divided by t2, or we can, let us say if this distance is t2, then we can write v2 is equal to d2 upon t2. Now we have the data related to this, so we can write what is v2 st. 2.5 is equal to d divided by t2 time. Okay, now this is the second equation. Now after reaching to point C, the swimmer is walking in this particular direction with velocity u. So we can write u is equal to what is the distance divided by t3, because we have assumed that it is taking time t3 from point C to point B. Okay, so u we can write what is d dash. D dash is nothing but the d1 is equal to d times tan theta if this is theta, and tan theta we can write 2 divided by 2.5, because this is this velocity is how much? 2 kilometer per hour, and this velocity how much? 2.5 kilometer per hour. So this tan theta is equal to this velocity divided by this velocity. Okay, so from here we can get d1 is equal to 2 upon 2.5 into d. Okay, so we can substitute here. So d1 divided by t3, so u is equal to 2 divided by 2.5 5d into t3. So this is our third equation. Now in the problem it is stating that the time covered by the swimmer 1, that is T1, is equal to total time covered by the swimmer while reaching from A to C and C to B. So which is T2 plus T3. Now substitute the value of T1. What is T1? T1 is nothing but D upon 1.5. What is T2? T2 is D upon 2.5. What is T3? T3 is 2D upon 2.5 into U. Okay, D will get cancelled. So this will be 1.5 is equal to U plus 2 divided by 2.5 U, and then we can write 2.5 U is equal to 1.5 U plus 3, and then U is equal to 3 km per hour. I hope the procedure is clear. Let us summarize once again. So in the question it is asking that there are two swimmers who are living from point A to point B right across on this particular bank, and one of the swimmer is actually going in this particular direction. It is not swimming in this direction, but it is going in this direction, and the stream has velocity of 2 km per hour. Because of this, the swimmer has to swim in this particular direction with respect to the stream direction, so that it will go in this direction. Now if we talk about the second swimmer is actually swimming in this particular direction, and because of the stream velocity it is going in this direction, and as it has reached to point C, it has to come back to point B. That's why it has to walk from point C to point B with some velocity u, and it is saying that time taken to go from point A to point B for swimmer 1 is equal to the time taken to cover the distance from point A to point C and from point C to point B is same. Okay, now what we have done, we have drawn the vectors for different velocity vector. So this is nothing but the stream velocity vector, and this is the velocity that is with respect to the stream. So this is the velocity of first swimmer with respect to stream, and this is the net velocity. Okay, so net velocity we have found out, and we have assumed that this is the distance d. We know that velocity is equal to distance upon time if we have the zero acceleration. Then we got the first equation, and then talked about the second swimmer who was actually traveling from point A to point C, and it was moving in this direction with respect to the stream with velocity of 2.5 km per hour, and this is the stream velocity. So it means that if we have the velocity in this particular direction, then what is the time taken to go from here to here? So that's why we have written 2.5 is equal to distance upon time taken to go from here to here is actually how much, t2, and then from here to here it is going with velocity u, and this particular distance is d times tan theta, and tan theta we have found out from the velocity in this direction divided by velocity in this direction. And then we have written the equation of total time taken by the swimmer 2 is equal to time taken by swimmer 1, and then we have substituted the value of t1, t2 and t3, and finally we got the value of u, that is the velocity by which it is walking on the other bank. I hope everything is clear and the entire procedure is clear. Thank you.